Hi, welcome to the Mathemagic channel. Today we look at how to solve this question, which is question 15 from the AMC 10 2022. Let's jump in. So before we begin, the typical way that we would look at a question like this is to try and think about the area of the circle and subtract from the area of the circle the area of the quadrilateral. So we might try and do AC minus area of quadrilateral. So how do we find the area of a circle without having a radius? Well, that might be a bit difficult. So we will need to find a radius. This is the first question that we need to ask ourselves. And then how do we find the area of the quadrilateral since it's a scalene quadrilateral? It's a little bit difficult, it's not obvious, but there are some formulas that can help us here, and perhaps we can look at everything now. So it seems to be that if we were to draw a line straight through here, it almost appears like this is a line that's a diameter, but in mathematics we can't really make any assumptions. So let's ask ourselves if AC is a diameter here. Well, if AC was a diameter, then the triangle ACD would be right-angled. And is the triangle ACD right-angled? So this is where Pythagorean triples can really help us, because if you take the 3, 4, 5 triangle and you multiply it by 5, you get the 15, 20, 25 triangle. And since we have 15 and 20, it's safe to assume that the hypotenuse is 25. Also, any triangle inscribed in a semicircle is right-angled. And so we can assume safely that the triangle ADC is a right-angled triangle at D. Now, equally, the triangle 7, 24, 25 is a right-angled Pythagorean triple. And so the triangle ABC is also right-angled, and therefore AC is a diameter. And so it's safe to understand here that AC, since it needs to be longer than 24, is probably just about 25, and that the hypotenuse here is 25, and that this is indeed right-angled. Now, if the hypotenuse is 25, the radius will be equal to 12.5, so half of the hypotenuse. And in this case, we can use the area of the circle formula, which is pi r squared. And so the area of our circle will be pi times 12.5 squared. And 12.5 squared, you can use a calculator for that. Or you can do 12 times 13 and add 5 squared at the end. Now 12 times 13 is 156, so this will be 156.25. If you'd like to know how to square numbers that end in 5, you can watch the video that we've made to show you how to square numbers that end in 5. So this is going to be 156.25, because we need 2 decimal points, pi. And this is the area of our circle. So now that we know that the area of our circle is 156.25, we need to find the area of the quadrilateral. There is a formula you can use here. It is called Brahmagupta's theorem. So this theorem allows you to find the area of a cyclic quadrilateral, which means a quadrilateral inscribed inside of a circle. It's very specific, and if you haven't seen that theorem before, I suggest you go watch our video, which will explain it to you in less than 3 minutes. In this case, we can absolutely use it since we have all the side lengths. And for your reference, here is Brahmagupta's theorem. We find the semi-perimeter and we subtract each side length from the semi-perimeter, and then we square root it. So let's go ahead and find the semi-perimeter here. It's going to be 24 plus 20 plus 15 plus 7, all of that divided by 2. So we can find this result divided by 2. So 24 plus 20, that's going to be 44. 15 plus 7 is 22. So 44 plus 22 is 66. So we end up with 66 divided by 2, and this will give us a semi-perimeter of 33. So to find the area of our quadrilateral, this might be a little bit big, so let's start off on the side here. The area of the quadrilateral then is going to be the square root of, and I'll try and write this as small as I can, 33 minus 24, factor of 33 minus 20, factor of 33 minus 15, and this also has to be multiplied by 33 minus 7. So this is going to be the square root of 9 times 33 minus 20, which is 13, times 33 minus 15, which is 18, times 33 minus 7, which is 26, which will give us the square root of 54,756. And this value actually happens to be exactly 234, which is absolutely beautiful. So this is our area. And so to complete the question, we can say that the yellow area, or the area that is shaded, is equal to the area of the circle minus the area of the quadrilateral. And in this case, the area of the circle was 156.25 pi minus, in this case, 234. Now, in the actual Olympiad paper, the question was asking to find the sum of certain digits which make up the area. But for the purpose of this question, the way it's been presented here, this is a very, very good place to stop. And this is a fine answer. So we found the shaded area and we're very happy. Thank you so much for watching this video. What a wonderful question involving Brahmagupta's theorem, which is not very often seen, as well as Pythagorean triples and the Pythagorean identity. We really appreciate you being here, so make sure you click the like and subscribe buttons, and we shall see you in our next video. Thank you so much.